Namaste. Welcome to Pythagoras Academy. In this video, we'll try to learn constraint equations, specifically pulley constraints. So when you have multiple pulleys in a system, how to find the relation between the accelerations of two blocks. Let me explain the concept of deriving constraint equations by taking a simple Atwood machine. In a simple Atwood machine, the relation between acceleration of m1 and m2 is so obvious. If m1 goes up by 1 meter, m2 would certainly come down by 1 meter. So if the velocity of m1 is 1 meter per second up, then velocity of m2 would be 1 meter per second down. If acceleration of m1 is a up, then acceleration of m2 is a down. That is clearly understood. We don't need constraint equations to solve this case. But I am taking this just as an example to understand the steps that we have to follow to derive constraint equations for any system which is having multiple pulleys and blocks. Step number 1, take a fixed reference line. So take a fixed reference line. So in this case, this line would be the fixed reference line. The reason why we take fixed reference line is because we get the accelerations with respect to ground. If we take a movable reference line, then we get accelerations of the blocks with respect to that particular line. So that is the reason, to avoid any complexity, we take a fixed reference line so that we get absolute accelerations, which means accelerations with respect to ground. Now from the fixed reference line, give constraints to the give variables to the movable points, variable lengths to the movable points. So m1 is movable, so let me say m1 is at a distance x1 from the reference line, and m2 is movable, m2 is at a distance x2 from the reference line. Now step 3, the length of the string connecting m1 and m2 or connecting the blocks passing over any pulley will always remain constant. Though the blocks are moving up and down, the length of the string will always remain constant. So write down the length of the string in terms of the variables that you have taken. So the length of the string in this case would be x1 plus this string which is on the circumference of the pulley, on the rim of the pulley. So let me say r is the radius of the pulley, so that pi r would be the length of the string which is lying over the rim of the pulley, and you have x2. So x1 plus x2 plus pi r, that is equal to length of the string which is constant, or I can say x1 plus x2 is equal to L minus pi r, which is constant. As the blocks move, as m1 is moving up or down, so m2 will move down or up, x1 changes and x2 changes, but they follow this equation. x1 and x2 will change such that the sum x1 plus x2 remains constant. So the motion of m1 and m2 is constrained by the string. That is the reason these are known as constraint equations. So x1 plus x2 is constant is the constraint equation for this particular case. Now you differentiate this, dx1 by dt plus dx2 by dt, that is equal to derivative of constant which is 0. dx1 by dt, the rate at which x1 changes with respect to time is nothing but velocity of block 1 plus the rate at which x2 changes with respect to time is velocity of block 2, that is equal to 0. So this is the constraint equation of lengths, constraint equation of the velocities. Now differentiate this, what you get is dv1 by dt plus dv2 by dt, that is equal to 0, which says that a1 plus a2 is equal to 0. This is the constraint equation. a1 plus a2 is equal to 0. Let acceleration of block m1 be a up. Let a1 be a, then a2 is minus a. So what does minus a mean? A down, a in the opposite direction. So this is the meaning of a1 plus a2 is 0. This is the constraint equation governing the motion of m1 and m2. Now let us apply the same concept that we have learned now in this case. Say there are two pulleys, one fixed pulley, one movable pulley connected to the block. So what is step number 1? You have to take a fixed reference line and give variables to the movable points. So I'll say x1 to m1, and I can directly give x2 to pulley. Actually, I can give x2 to the block, then xp to the pulley, but the acceleration of the pulley is same as acceleration of the block, because pulley is directly connected to the block with a single string. If the pulley or the center of the pulley is moving up with an acceleration a, certainly m2 will also move up with an acceleration a. So we don't have to take more number of unknowns and complicate the situation. I can directly take or give variable to the pulley. So I get velocity of the pulley or acceleration of the pulley. So that is same as the velocity of or the acceleration of the block. Now I will express the length of this big string connecting m1, passing over the fixed pulley, then passing over the movable pulley and connected to the ceiling. This big length, I can write it as x1. So it is x1 plus, so this length would be say pi r plus, and this length from here to here, this would be x2 plus the length of the string which is on the second pulley, let it be pi r dash is a radius, plus again till here it is x2 plus, let me take this distance to be some d which is constant fixed, that is equal to length of the string. Every time you don't have to take pi r dash and all, directly we can get the relation between x1 and x2. So the relation is x1 plus 2x2. Basically it is x1 plus 2 times of x2, and all other things are anyways remaining constant, which will be equal to constant. This is the constraint equation. Now differentiating this, we get v1 plus 2v2 is equal to 0, and differentiating this equation we get a1 is equal to, or a1 plus 2a2 is equal to 0, a1 is equal to minus 2a2. Now what is the meaning of it? If acceleration of m2, suppose if it is a up, if a2 is a, then what is a1? It is minus 2a, in the sense opposite direction and twice the acceleration. This is the relation between acceleration of m1 and acceleration of m2. Now the same thing we can also understand this way. Suppose the pulley goes up by 1 meter. Suppose pulley is going up by 1 meter. How many meters of string is released? 1 here and 1 here. So 2 meters of string is given to the block m1. So m1 would come down by 2 meters if this is 1 meter. So if the pulley goes up by 1 meter or m2 goes up by 1 meter, then m1 is coming down by 2 meters. So if the velocity of m1 is 1 meter per second up, then if the velocity of m2 is 1 meter per second up, then velocity of m1 would be 2 meters per second down. Or if the acceleration of m2 is a up, the acceleration of m1 will be 2a down. It is very simple to understand. Even in this case, you don't need constraints. So basically constraints are used when you have more than two blocks and multiple pulleys. So sometimes constraint equations will help you to understand the relation between the accelerations of two different blocks. All right. Now let us take another example. Yeah. This case, again, take a fixed point, fixed reference line. So I'll take this to be a fixed reference line. This is a fixed reference line. From here, give variables. So let this distance be x1 and this be x2. This is the fixed reference level, and this length is anyways constant. It is remaining constant. This length on the pulley will also remain constant. So what is the constraint equation? You can directly write it as, or you can take x1 till here. This is x1. So it is x1 which is changing, plus x1 plus x1 plus x1. What do I have? 4 times of x1 plus this is constant and this length is also constant. So this is a single string which is passing over 3 pulleys and the big pulley and connecting M2. So 4x1 plus remaining lengths are constant, which is there in this on the rim of this pulley and on the rims of the other 2 pulleys and on the rim of this big pulley. So those are constants and this length is constant, and what is variable is then x2, that constitutes the length of the string. So the constraint equation would be 4x1 plus x2 is 0, differentiating this 4v1 plus v2 is 0, or 4a1 plus a2 is 0. This is the constraint equation. If a2 is a, then, or if a1 is a, then a2 will be equal to minus 4a. So what do you mean by a1 is equal to a? Suppose the bigger block is moving towards right with an acceleration a, then the smaller block is having acceleration minus 4a. How do we understand this minus sign here? If the direction of acceleration of m1 is in the direction of decreasing distance, if you are taking the direction of decrease of distance as positive, then the direction of increasing distance will be negative. So if m1 is accelerating towards right, the distance x1 is decreasing, certainly x2 will increase. So the direction of increase of the distance x2 will be down. So if positive is taken to be right, for m2 the negative value is towards down. So minus 4a implies it is down. So this is how you interpret this minus sign, and this is equal to 4a. So if the bigger block moves with an acceleration a towards right, the smaller block m2 moves with an acceleration 4a down. Without constraints, how do you analyze this? Suppose if m1 is moving towards right by 1 meter, then pulley moves towards right by 1 meter. This pulley is moving towards right by 1 meter. So how many meters of string is released? 1, 2, 3, 4. So 2 meters is given here from this pulley, 2 meters is given from this pulley. All over 4 meters of string is given to m2. So m2 is coming down by 4 meters. So this is 4 meters if this is 1 meter distance. So it is so obvious that if m1 moves towards right by 1 meter, m2 is coming down by 4 meters. Or if the velocity of m1 is 1 meter per second, then the velocity of m2 would be 4 meter per second downwards. Or if the acceleration of m1 is a towards right, then acceleration of m2 would be 4a downwards. So even by this general logic, you can understand the relation between acceleration of m1 and acceleration of m2. So this is the simple concept of constraint equations when you are working with pulleys. Of course, when you are working with wedges, the way how you deal with constraints is different. That we'll try to cover in a different video. Thank you.